Hi, third graders. This week we're going to be taking what we know about multiplication facts and using that to find the area of rectangles. Our target this week is that you'll be able to show that the area of a rectangle is the same as if you multiply the length of the sides. So, we're going to be building off of all the rectangle array learning you've done in second grade and third grade to figure this out. Before we get going, I'd like you to take a moment and pause the video in just a second and find a rectangular array somewhere around the house. Remember, an array is a rectangular shape filled with equal sized squares. I found one a minute ago. This game board. It is a square shape and it's filled with equal sized smaller squares. They're organized in rows and columns, as all arrays are. So you could find a game board like I did, or maybe there's a window with squares of glass, tiles on the floor. As long as it's filled with equal size pieces that are rectangle shaped, you're good to go. So we'll be using that at the end as an extension or challenge problem. So pause the video and go find your array. While you're doing that, I'll be drawing a rectangle to get us started. See you in a minute. Okay, I hope you found your array. We'll come back to that at the end of the video. And I've drawn a rectangle here for us to talk about. So let's think way back to the beginning of second grade. When you saw a rectangle like this, you would figure out the area, the space inside, how many squares it takes to fill, by counting one by one. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And you'd find out that the area was 12. But then in second grade, you learned about rows and columns. Remember, rows go across like you're sitting in a theater. Here's one row, 2 rows, 3 rows, and 4 rows. Then you would use repeated addition in second grade, so you could add up how many were in each row. Let's see, 3 plus 3 plus 3 plus 3 equals 12. So you'd find the area by adding up the rows. In second grade, we also found the area by adding up the columns. Same strategy, but now we're thinking about columns which go up and down. Thinking of maybe columns holding up a building if you have trouble remembering that. So if we add the columns, there are 4 in each column. 4 plus 4 plus 4 equals 12. But this year in third grade, you figured out that anytime you're using repeated adding, that's the same as multiplying, and multiplying is a more efficient way to solve these problems. So you could have gone 4 groups of 3, that's the same as 4 times 3. Or here, where there's 3 groups of 4, you could have seen it as 3 times 4. Either way, the area is still 12, but these are much quicker for your brain to do than adding all of those up. Remember, as we go forward in math, it's all about making things more and more efficient. Now, seeing these numbers, 3s and 4s, you can see them in the side lengths of this rectangle. The rectangle is 4 squares tall, and it's 3 squares across. We call those the dimensions of the shape. Dimensions is a fancy word for measuring the size of something. So this shape is 4 squares tall and 3 across, and those are its dimensions. When you're finding the area of a rectangle, you multiply the height times the length. In fact, we could write that as an equation if we wanted to get really fancy. A for area equals, now we could say length times height or height times length. It doesn't really matter because you can flip-flop in multiplication. Let's do length times height. You can use that to find the area of any square or rectangle. Whenever you need the area of a rectangle or square, multiply the length times the height. Let's do one more practice together. Okay, here we have a slightly bigger rectangle. And again, all of your second grade strategies would still work, but we are trying to get more efficient. So we're going to use that equation we figured out, that the area equals the length times the height. So how long is this rectangle? Let's see. Well, we can count how many squares long it is. 1, 2, 3, 4, 5. The length of our rectangle is 5. That's one of its dimensions. Again, dimensions just means measurements. And the height is, you got it, it's 4. 1, 2, 3, 4 tall. Now, to solve this equation and find the area, area equals the length of 5 times the height of 4. Now you know 5 times 4. 5 times 4 is 20. So the area of this shape is 20. If you weren't sure, you could go back and double check using skip counting. You could count, if there's 5 in each row, we could go 5, 10, 15, 20. It's that repeated adding, but a little faster with the skip counting. Or you could go 4, 8, 12, 16, 20 across the columns. Either way, the area is still 20. You'll be practicing this in your Bridges book this week, getting the dimensions and using those by multiplying them together to find the area. Before I get the Bridges book out though, this would be a great time to pause your video, go back to that array you found somewhere in the house, like my game board, and see if you can figure out its area using this same strategy. Find the length of it, find how many squares or rectangles high it is, and multiply them together. While I get my Bridges book, you go ahead and do that. I hope you had fun finding the area of something in your house. At our Wednesday meeting, I would love to hear what you measured and what its area was. So this week, our Bridges pages are 178. They have rectangular arrays for you to write down the dimensions, tell the area, and show what equations you could use to figure it out. The directions do say write 2 different equations to show how you found the area. In their example, they did the repeated adding equation and the multiplication equation. So remember, I'll be looking for 2 equations here, the correct area, and the dimensions being labeled on the shape. The other page to do is 182. Similarly, you'll need to label the rectangle with its dimensions and tell the area for those 3. And at the bottom of the page, there's some multiplication practice, because multiplication is completely essential to finding the area of shapes. That's all for now. I'll see you in the next video.